One of the important concepts in object-oriented systems is coupling, which determines how much a class is coupled or dependent on another class. For example, here in the main class, we're using the user class, so the main class is coupled or dependent on the user class. So if we change the user class, the main class might be affected. We may have to change it, or at least we have to recompile and redeploy it. Let me show you. So I'm going to go back to the user class and introduce a new parameter in this constructor. Let's say integer age. So we have changed the user class. Now, the main class is broken. We cannot compile this code. We have to pass this argument over here. So this is the problem with coupling. Let me show you another example. Back in the user class, let's add a hyphen before this message. Now, back in the main class, we don't have a breaking change. Our code compiles perfectly well. However, because we have changed the code in the user class, this class has to be recompiled. And that means all the classes that are dependent on this class have to be recompiled as well. Now, this is a very simple program. We only have 2 classes. But what if we had hundreds or thousands of classes and many of them were highly dependent on each other? In an application like that, if we change a class, we could end up with lots of cascading changes. An application built this way is really hard to change, hard to extend. Let me give you a metaphor. Think of your car. If you get a flat tire, you only need to replace that tire. You don't need to replace the steering wheel or the engine, right? Your car is an example of a loosely coupled system. The components in your car work together, but they're not tightly coupled or dependent on each other. So you can replace individual parts independently. Our applications should be the same way. But how can we build loosely coupled applications? Using interfaces. And that's what I'm going to cover next.